On this video, I will be applying properties of similar triangles, specifically triangle proportionality, triangle angle bisector theorem, and two-transversal proportionality. So with the first example, I'm asked to find the length of segment FI. For this first one, I'm going to use both the triangle proportionality theorem and the converse. So the triangle proportionality theorem states if a line parallel to a side of a triangle intersects the other two sides. So basically, this is what it's saying here. I have two parallel lines right here. So if it intersects the other two sides, then it divides those sides proportionally. So these sides are proportional. The other theorem, it says, if it's a converse, the converse of the triangle proportionality theorem states if a line divides two sides of a triangle proportionality, then it is parallel to the third side. So those are the two theorems that we're going to work with. I would highly suggest that you go ahead and set up your proportions based off of the points that are given and then go back and substitute. So I'm looking here and I do have some given information, but it's not enough. If I'm looking here, I would assume that I have two variables, but really I don't. I can go ahead and figure out the one with the question mark because I understand segment addition postulate. That says that this segment plus this segment equals the entire segment. So in essence, it's saying x plus 18 equals 30. I can just work backwards. 30 minus 18 would equal what? And once I simplify that, I can figure out that, oh, that's going to actually equal 12. 12 plus 18 equals 30. So that's what I'm going to use in the place of Fs. And what I'm trying to find is the length Fi. So I'm just going to go ahead and label both of those and substitute. So I have x for Fi. For IR, I have 30, setting it equal to Fs, which is 12, over St, which is 18. Now you want to just cross multiply. And so now that leaves me with 18x is equal to 12 times 30, and we know that's going to be 360. Divide both sides by x will be 20. So x was what I just called Fi. So we're just going to rewrite this as Fi is equal to 20. So that's my answer if I am using the triangle proportionality theorem. Now let's go back and say that maybe we were actually given that Fi was 20 to begin with. So we could use the converse of the triangle proportionality theorem, which will prove that the lines are in fact parallel if the sides are proportional. So how will we know if the sides are proportional? Do the same thing. Go ahead and substitute what you know. So Fi is 20, IR is 30. Set that equal to Fs, which is 12, and St, which is 18. And now if I simplify both sides, I see that this is 2 over 3. Dividing both 12 and 18 by 6, I'm going to get that same 2 over 3. So yes, I just verified or confirmed or proved that these lines are in fact parallel that are shown here. They're parallel. So that's what the converse theorem tells us. Okay, moving on to example 2. For example 2, we are asked to find the length of segment PL and the segment LU, but this time we're going to use the triangle angle bisector theorem. And it says an angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So whether maybe you don't see it, but there are two triangles here. So there's one here, and then there's another one here. So what we're trying to do is set up a proportion, and we're going to set the bases together. And then if we started with that left-hand side, we're going to start again with our next fraction on that same side. And then those two we're going to put together. So this is what it would look like if I actually go ahead and substitute what I know. For PL, I have y over 2. And then for LU, I have y minus 4. Setting that equal to PS, which is given as 10, and US, which is given as 12. Fraction set equal to another fraction, I want to go ahead and cross multiply. If I have an expression, I have to distribute. This is an expression. I'm going to have to distribute that 10 to that. All right, so on one side, I have 12 times y divided by 2, set equal to 10 times y minus 4. And like I said, I'm going to have to distribute. And this is simply 12 times y divided by 2, or you can cross simplify. 12 divided by 2 leaves me with 6. And so now I have 6y is equal to 10y minus 40. And now I want to combine like terms. I'm just going to do 2 steps at one time. Subtracting 6y on both sides and adding 40 on both sides. So now I can get rid of my y's on this side and get rid of the 40s on this side, sorry. And I have 40 is equal to 4y. And once I want to try to find y, so I'm just going to divide both sides by that 4. Y is equal to 10. If I go to my directions though, it does not ask me to stop when I find y. It asks me to find PL and also LU. So what I'm going to do is take the information and I'm going to substitute it in. So for PL, I said that y was 10, and 10 divided by 2 is 5. So PL is 5. And then for LU, y is 10, and subtracted the 4 from it, and that's going to give you 6. So those are the answers for example 2. For example 3, it looks like this. It says, find the lengths of segments shown below. When we're referring to this one, it's a two-transversal proportionality. If 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally. So again, I can go ahead and set up my proportions, which I've done already, and then I'm going to substitute accordingly. So based off of CA, I see that that's x, AT is x plus 2, RF is x over 2, and FY is x minus 2. I'm just trying to challenge you. It doesn't have any number, so we're going to have to figure out what x is and then go back and find the lengths of the segments. So again, I see a fraction set equal to a fraction, so I want to cross multiply. I also have expressions, so I'm going to have to distribute. So for this side, I have x times the quantity of x minus 2 is equal to, and then on this side, I have x plus 2 times x over 2. Or you could write it the other way, it doesn't matter. Just make sure you distribute on this side. All right, so I'm going to distribute, and I'm going to have x squared minus 2x equal to, and then x squared plus 2x, all divided by 2. And now, in order to get rid of that denominator of 2, I'm going to multiply both sides by 2. And so, since there's an expression here, that's going to actually be 2x squared minus 4x, because I have to distribute. And this side, I got rid of the denominator, so I now have x squared plus 2x. And I want to combine like terms. So in order to do that, I'm going to have to subtract everything on the right-hand side over to the left-hand side and set it equal to 0. And you know what that means? That means we are about to factor. And the reason I did that is because every term had an x on it, so I have to combine them all on one side. So I have x squared minus 6x, and my greatest common factor is x. I'm left with x minus 6 is equal to 0. And I set each one of my factors equal to 0 because of the zero product property. And then x minus 6 equal to 0. What would make that true if I were to put something in the place of x? X would have to be 6. So we know that the side length can't be 0, so that's not even an option. We're just going to go with 6, which happens to be the length for CA. This one right here is simply x. And now if we want to find the length for RF, we would take that same 6 and divide 2 by 2. So that's going to be 3. For AT, we're going to take that 6, add 2, and that's 8. And then finally for FY, we take 6, subtract 2, and so we have all of our side lengths using the different theorems that were given to us. Okay? Have a good day. Like and subscribe.
Subscribe.